Good morning, my scholars. There's one thing I really need to talk to you about before we get started with our foldable thing that you did on Friday. And that's, what is this unit circle anyway that I keep talking to you about? And if you did want to look in your book, okay, it is on page 460, but I'm just going to give you like a 1 or 2 minute briefing on what is a unit circle. When we say unit circle, think of this as an XY coordinate grid. Here's the origin, okay? If you drew a circle that has the same radius, obviously, and it was only 1 unit, so from here to here is 1. All your radii, of course, are going to be 1. This is 1, and this is 1. All of those radii are 1. We call it a unit circle. So that means that you can actually figure out what coordinate this point is. If this right here, if the center, right, is the origin at 0, 0, then this point here is going to be 1, 0. If we move from quadrant 1 to quadrant 2, or straight up here, then this is going to be 0, 1. This point over here is going to be -1, 0. And finally down here, it's going to be 0, -1. And that's all basically what the unit circle is. Then we're going to talk about some other things about how to find angles on this unit circle, but that's the basics of it. Okay, there's one last thing I'd like to talk to you about, and that's that if you did want to know the equation of this circle, let's say you wanted to graph it on a calculator, the actual equation of the circle is x squared plus y squared equals 1. If you did want to put it into your graphing calculator, you know when you do the graph function, it has to look like y equals the square root of 1 minus x squared. But that will only give you the positive half of the circle. So if you want to see both halves, you also have to put in 1 minus x squared. So this is, if you want to see it on your graphing calculator, this is how you have to put it. Okay, I wanted to mention that because some of you have it. And that'll give you both halves of the circle. We're going to talk a little bit in the next video about exactly what it looks like. But again, if you want to see the official book picture, look on page 460. Okay. So the next thing we're going to talk about is how to refer to parts of the unit circle. So I have another unit circle here. I just sketched it. And you need to know that theta is the central angle. So whenever we talk about theta, it's always here near the origin. Okay, and we're going to start always here. This is our starting point, and this is what we are going to call 0 degrees. Because if you go straight over here, there's no degrees. We're always going to go up this way. We're going to call that the positive direction. My pen's giving me fits and starts again. So we're going to call that the positive direction. So if I want to go up to where theta is some degree up here, then the angle measurement that we're talking about is from here to here. That's theta. It's a positive angle. If you go the other direction, so you start at 0, but you go down, okay, that's going to be a negative direction. And so you can go from 0 up and around counterclockwise, positive, or you can go clockwise, but we're going to call that negative. So it starts at 0. If you think about this angle, theta, then this is 90 degrees. Once you get here, if you continue around your circle, then this one's 180 degrees. Because again, we're measuring from the center. If you continue down here, then you're going to get to 270 degrees. And if you continue this way, you get to 360 degrees. So 0 and 360 are in the same location. A little bit more on the note taking that you need to know. So I've got my unit circle again, and I'm going to measure the angles around the origin, those central angles, those thetas. So something you need to always know is that this side right here is where we're always going to start. And since we always start here, we're going to call this the initial ray, or the initial side of our angle. So let's say I want to draw, okay, for instance, let's say I want to draw 52 degrees in theta. Then I start here and I move up my circle. About halfway is 45. So a little more than halfway is going to be, say, around here. And so I draw the other side of the angle about here. This one, where you draw the second one connected there, this is called the terminal side. Terminal side. The initial side is always along the x-axis, but the terminal side can be anywhere else on the circle. And so that is referring to this angle here, and this is 52 degrees. So since we have that terminology down, let's say I also want to mark, let's say, 243 degrees. Okay? So what you would want to do, again, you start at 0. I should erase this stuff. So you start at 0. I'm going to take the terminal side out so I can redraw it. Okay, so I want to draw the angle of 243 degrees. I start here at 0. I'm going to go up here. I go 90. Okay, here's 180. Now this is 180 here, where I'm at now, and this is 270. Then I know 243 is here in the third quadrant. Well, how far down am I going to draw it? Well, it's going to be past 180. How far? Just do a little subtraction. And so it's going to be drawn, that's 45, like around here. Okay. Where the angle from 180 to 243 is 63. But if I asked you to mark the entire angle, okay, the entire angle, that's 243 degrees. Here's your initial side, here's your terminal side. And then lastly, if I wanted to know what would this angle be here if I wanted to know the negative direction. Because remember, this is positive direction. So this is 360. How much would I have to subtract to get to here? So you do 360. You're going to take away 243, right? So then this angle here is 117 degrees, but it is negative. So if I ask you to draw negative 117, they're the same. And in fact, when you draw the same green angle there, and you can either list it as 243 positive or negative 117 degrees, then we call that co-terminal. Right, this is your initial side, but this is your terminal side. And so if they both have the same terminal side, we call it co-terminal. So next, I just want you to understand everything I've been talking about here, where this is 0 and this is 90. Whenever we draw something, we're drawing in what is called standard position. And this is your, introduction to the unit circle. So make sure, if it says draw in standard position, follow these rules. One other thing I wanted to show you, well, what if you're supposed to draw an angle that's not between 0 and 360? Okay, because we're supposed to be on this circle. Well, here's 0, and that's also 360. So all you have to do is just keep going around until you find it. So let's say I want to know where is 500 degrees. Where's 500 degrees? If I was going to draw that, I'd start here at 0. There's 90, there's 180, there's 270, and there's 360. I just keep going. So there's 450, right? This is 360. And so I would do another 50 degrees here. Oh, I wanted that to be green. And then this terminal ray, it'd be 50 degrees into my second quadrant. That's 50 degrees. But really what I'm drawing is the coterminal angle where that is 500 degrees. So you can do it either positively or negatively. And so we're going to give you a few problems where you're just going to practice drawing the angles on the unit circle. Eventually, we're going to use that foldable to find special angles. But right now, if you just want to know these angles, that's how you're going to do it. And I'm also going to ask you to take a look at page 460. As I mentioned in the beginning, has 3 problems at the bottom of it where you can clearly see what those are. Okay. And this should be enough notes for now until we get to 9.2. Next, we're going to talk about how to change radians into degrees, degrees into radians, and what the heck are they anyway? So I'll see you probably tomorrow. Put these in your notebook. Keep them at the ready.